DFSense is the only router I know of that does any kind of validation of their HTTP host headers or anything like that. So, okay, let's say that you are vulnerable. This works. There are some very simple steps you can take to stop it as an end user. Okay, first of all, we can basically break any of those 3 requirements we have for the router, and if any of those are broken, the attack doesn't work. And we can also reduce the impact of the attack just by basic security measures. So if you have sufficient access to your router, you may be able to change the services so that they only bind to the internal interface. So a lot of these services, though, that are running on these are very, very simple. So even if you get, command line access and you can reconfigure that, there's no guarantee that it will even allow you to tell it to only rebind to a single interface. A lot of them just rebind to everything, all interfaces, and you can't control that. But if you can change that, that's a good way to stop the attack. You can also reconfigure your firewall rules. Basically, anything coming from your internal interface that's going to your public IP, drop it. Now you notice I went ahead and I used the /16 because as soon as your public IP changes, you'll have to update that rule. So go ahead and figure out the net block that your ISP uses to hand out as DHCP addresses, and just put that whole net block in, and then you don't have to update the rule anymore. Disable HTTP and enable HTTPS. Now people here in this room, I hope that you know how to use SSH. If you can use SSH, please do. Again, a lot of consumer routers don't allow SSH, but that's fine. If you're enabling HTTPS, you have to disable HTTP. Just enabling HTTPS doesn't help you because that means I can still rebind to the HTTP interface. You have to make sure you also disable HTTP. Disable UPnP as well if you can. I know a lot of people rely on it, so that might be difficult. Some routers don't let you disable HTTP. There's just a checkbox to enable HTTPS. Some routers also bind the HTTP interface to multiple ports. So this one, for example, it runs on port 80 and port 8080. So when you disable HTTP, you have to make sure it disables all of that. Again, HNAP, that's a whole other talk in and of itself. But some routers don't let you disable that at all. If you don't have sufficient access to your router to do this, you can basically do the same thing on your host. Okay? Because I have to use the host to access the router. I'm proxying everything through your web browser. So basically do the same rule. Anything destined for your router's public IP, drop it. Or you can configure dummy routes. Anything going to your public IP, route it to your loopback address. The downside to this is you have to do it for every single device on your network and every single device that will ever connect to your network in the future. That includes, your friend's iPad when he comes over. Basic security precautions. Change your default passwords, please. Just do it. It's a good idea. Keep your firmware up to date. Again, a lot of these routers have a lot of vulnerabilities in them. And if you're lucky, your vendor will actually patch them. So make sure you keep that up to date. And don't trust untrusted content. And yes, the internet is untrusted. This is kind of a good suggestion. It's not really practical for most people. You can't tell them disable JavaScript or use no script. It's just too much of a hassle for them. But it's definitely something to be aware of. So for vendors, okay, the problem is with the same origin policy in the browsers. I know I've seen people say, you can fix this in DNS. No, you can't fix this in DNS. It's not a DNS problem, and it's not really fair to blame DNS for this. Because the problem is that the same origin policy chose an insecure protocol that was DNS, which was never designed for security and designed to base a security model on it. So it really needs to be fixed in the browsers. Implement the strong end system model on your routers if you're a vendor. Also build DNS rebinding mitigations into the routers. That means checking your HTTP host headers, which is typically not terribly difficult. So, wrapping up, yes, DNS rebinding does affect you. Yes, there are tools out there to attack your router, your internal resources with DNS rebinding, and ultimately you are responsible for your network. You can't rely on vendors to fix this because they'll either do it wrong or they won't do it at all. So make sure you go ahead and take mitigations yourself to fix your stuff. So with that said, the code for this should be on the DEFCON CDs. I'm also going to keep it updated on rebind.googlecode.com. Again, death threats, send them to my Gmail account, not to my work. And with that said, do we have time for Q&A or are we out? Okay, I'll be in room 113 if anyone has any questions. Also, feel free to grab me if you see me walking around or send me an email.